Hello everybody, my name is Alex and this is video about my DIY camera project and how I made it, why I made it. This is part 1, so there will be part 2, and just ensure that you didn't miss, so subscribe, give a like, and we are starting. Enjoy it!
So, hello everybody, and it's actually time to show the first prototype of this project. So I have everything I need. I have my LED matrix. I bought LED matrix. I have STM chip. I have GPIO converter. I have multiplexer. I have multiplexers and I have ADC. So time to get soldering iron.
The real reason why I'm using a prep board instead of proper PCB is because this approach is very experimental. So I will have no idea if it will be working at all. So the idea is following. I'm taking 64 by 64 matrix. Using multiplexer, I can actually control where and which pin I will need to select from this matrix. Using ADC, I'm reading these values, and after that, I can, using microcontroller, read the value of each pixel, and then inside the microcontroller, inside the buffer, I'm building the frame of 64 by 64. Again, somebody will be say, you can use breadboard, you can use whatever. When you have so much amount of connections, the connections on a breadboard can be very funky and it can take ages and ages to troubleshoot. So I decided to solder it, and even there I got some problems and we'll be figuring out them later.
Okay, first connection to the computer, and if I connect it to the board, everything working as well. So, Scamazon, fuck you. So hardware is more or less ready. I have a Starlink connected to my laptop, so I can start writing software, which will be basically read state of each pixel and try to display it on the screen. And so some cool updates is happening. First of all, don't buy cheap STM programmers from China. They're good for flashing microcontrollers, but they're absolutely shit when you need to debug your code. So right here I have original STM link from STM. It's quite pricey, but it's absolutely worth it. So here on the board we have a lot of changes. First of all, I get rid of all unnecessary electronics, and basically I'm using only 2 multiplexers, board and STM. I can quickly explain why it's happening. So, the reason behind it first is that it doesn't really need any STM. The reason behind that, it's actually pretty simple. So you don't need any ADC because the STM chips have 12-bit ADC inside, and probably it's one of the things I will be leave there as it, so I will be use, or I probably can use one ADC just to increase accuracy, but if I will be not really happy with 12 bits. But right now, for first tests, it's more than fine. Overall, I solder it directly pins from multiplexers because 6 GPIO, guys, come on. Any microcontroller right now have 6 GPIOs. It's not even a joke. So it's not even funny that I was been using an expander for that. Well, actually we have some success, which is basically I have some voltage over this large board. Next thing I need to do is to write simple software that will be basically wait for command and then just display all 64 combinations. But I will be really need a lot of things to get it tinkering.
And keeping all this in mind, I start designing PCB for my first prototype. There's some very important details about ordering PCBs. I'm ordering my PCBs over GOC PCB. It's not sponsorship. I wish it was a sponsorship. Guys, please slam GOC PCB support or something in the comments. I really need that sponsorship because PCBs are crazy expensive now. And one more detail I wanted to show about these PCBs. Ideally, as I'm having USB 2.0 on this PCB, I should use impedance matching. However, if I'm using impedance matching, the prices are just skyrocket. So what I'm doing is I'm specifying stack up. I'm saying that this one is stack up I need and just hope that everything will be work. Because I tried to calculate everything so the impedances will be matching. So, should be working.
One eternity later.
Next thing I started doing is soldering manually all the parts. And actually this thing was being very uneventful except one thing. I couldn't get any communications from microcontroller in the beginning, and the reason for that was being just bad soldering. So after I resoldered with microcontroller again, everything started working properly.
So I resoldered chip after yesterday, and absolutely fantastic news. I can see it by SDM Kuba ID. So now I need to check if that UART is working at all or not. So fantastic news, UART is working. And ideally what I need to do is check ADC and probably go and write some software. So guys, there is some actual result finally. So here you can see GUI app and it shows like dark. And if I will be showing like that, so you can see both. So I'm taking phone, going, and you can see it turning to the right, and it's turning to back. This is cool. So, time for presentation.
Thanks everybody for watching until this moment, and make sure you guys subscribe just because 2 more cool videos are coming until 2025 is being finished, and part 2 about this project it's coming in the beginning of April of 2026. I will probably using FPGA in that project, so it should be very, very, very cool. And one more comment about what's happening on this channel. Right now I'm using the following pattern for all videos I make. I have something done on a PC like PCB design or CAD design, doesn't matter really. Then I'm building the real thing and then I'm actually talking about it. In my opinion, it gets a little bit boring because it's the same repeatable pattern that continues from one video to the another. So right now I'm asking guys if you know something that I can improve in my videos about this pattern or just about general shooting, video editing, just let me know in the comments please. Stay creative, see you soon, and bye.